Hey everyone, welcome to another episode of Schools Out Science. So today we're going to be talking about pressure and how pressure actually works in our world.
Yeah.
So pressure is
how much force is exerted over an area.
Pressure is how much force is exerted over an area. Okay, so if I was doing force, what is force?
The push or pull on an object.
Okay, so here's an example. If I'm going to use Courtney first. If I'm going to take Courtney and I'm going to pull her all the way over, see how much easier when I had my force over an area was a lot bigger? Or I have Haley, I'm just going to push her. Okay?
Wow.
That's easy. I can totally do that. And that is what force is. Okay? That's what pressure is on an object. However, everything around us is made up of molecules. Okay? So when everything around us is made up of molecules, it means the air even has force. It has pressure. It's able to move, okay? And when there is high pressure and low pressure, I'm assuming you guys have heard that like in the weather, that is how stuff moves around, okay? We have hot air, we have cold air. They like to maintain balance. And when there's not balance, they're gonna force on each other until there is balance. So today with our experiment, what we're going to do is we're going to make it so I'm able to move an object without even touching it. How many of you guys think I can do that?
Yeah.
What do you guys think?
It's probably because in an earthquake nobody touches anything and they move, they fall over.
Because there was force on an object, right? Yep, that's exactly right. So for this experiment, what you're going to need is, like I said, stuff you can find around your home, which is going to be a
jar.
Glass jar. Please use glass, not plastic. Plastic will melt. You're also going to need a glass pie pan. And in the glass pie pan, you're going to want to put about, half an inch of water. You can put more. It's not going to hurt anything. And I colored the water, so during the experiment, you are actually able to see the reaction that's going to be taking place in the water. You want to get a tea light candle, okay? So these are really little, they're lightweight. You can use other candles, but they don't move as well, and I'll show you why. The last thing that you're going to want is
a lighter.
Yep. And kids, are you allowed to touch the lighters?
Nope.
Have a parent light the candle for you, please. So real simple, starting with this experiment is I'm going to go ahead and I'm going to take the tea light. I'm going to place it in the water, okay? Try not to get the tea light wet, otherwise it's not going to work very well. And then I'm going to go ahead and light the candle. Okay, now I'm going to move, hang on, before you put that on, Haley, I'm going to move my computer a little bit closer so you guys can actually see this on camera. Let me see here. Okay, so hopefully you guys can see this, okay? So what I'm going to do is I am going to put this glass over the top of, oh no, I just blew out my candle. Let me try this one more time. Try not to breathe, guys. Just kidding. Okay. I'm going to put my glass over the top of the candle, and I'm going to put it all the way down so it's touching. So there's kind of like a seal on the bottom. Did you guys hear that?
Yes.
Now, how many of you guys think the candle's going to keep burning? What do you guys think? What do you think, Haley?
I do not think it's going to keep burning because fire needs oxygen.
That's right. Fire does need oxygen. So this is going to be our chemical reaction right here. Oh, here it goes. And what happened, girls?
The water went up.
The water went up.
And it moved.
It moved. Let's go ahead and try it again. And I'm going to try it with...
See, it was concealed in the jar.
Yep. Did you guys hear that little plunk sound? I'll explain that. So we're going to try it one more time, and I'm going to see if I can show you guys a little bit better with 2 candles. This is going to be our second experiment. So Haley, go ahead and place both candles in the water. Courtney, we're not going to use that jar. I got a bigger jar. And this is kind of a second part to our experiment. Okay, this may take a minute to get lit. Okay, so very carefully, and this one's kind of tricky because I got to make sure... Now, 2 candles, is that going to make more heat in the jar or less heat in the jar?
It will make more heat because there's 2 candles.
So more heat means more hot air, which means it's going to have pressure that's going to want to move. Oh, here it goes.
And I think it's going to have more pressure.
Okay.
And because there's more camera.
So why does that happen though? That's what I want to know.
Because there's more heat in a smaller concealed area.
Yes. So basically what happens is when the warm air takes up more space, the candle heated up this area up here, okay? That's the warm air. As the air inside the glass gets warmer, it's going to expand, okay? And when it expands, it wants to have an equal balance with the cool air that's on the outside, okay? And to be able to do that, down here at the bottom, it's going to start escaping. And when it does that, it's going to restore balance with the high pressure inside to the low pressure on the outside. And then as the candle burns and then goes out, inside the glass, it's going to do what? Does you think it's going to cool the air, or is it going to be hot still?
Hot still.
It's actually cooling the air, because as soon as that flame goes out, there's no more heat. So when there's no more heat, the cold air inside the glass now has low pressure. Cold air, low pressure. What did I say? Cold air, low pressure, right? So when there's cold air and there's low pressure, then it's going to want to go outside to restore some of the balance. So when the cold air starts to move outside the glass, it's going to suck in the hot air. And when it's sucking it in, it's actually bringing water in with it that's going to make the water rise. So the low pressure inside the glass pushes on the water, forcing the water into the glass, and the water level keeps rising until the air pressure inside the glass is the same as the air pressure outside the glass. This is basically a mini weather chamber showing how it restores balance. Okay? So this experiment shows how all around us wants to maintain an equal balance. How hot air and cold air always want to maintain a balance. Okay? So at home, depending on what you have, you can actually do some pretty fun experiments with this. You can find different size glasses, and honestly, the smaller opening you have, the more of a reaction you're gonna see. I couldn't find my beakers, they're somewhere in my garage, but if you have one, or even have like a really skinny glass, you could be able to put it over the candle and it will suck in all of that water and you can really see the candle rise. So I hope you guys try this at home. If you have any questions, feel free to message me, and we will see you guys tomorrow.